In this video, I will cover the investigation of intermolecular forces and polarity in household chemicals. Firstly, we need to make sure we're using proper safety during the experiment. This will include safety goggles and nitrile gloves, and additionally, I will be using a hair tie. It's also important to have another person supervising, so thank you to Peyton for helping with this experiment. In the first part of this experiment, we will be looking at the melting points of our chemicals. We will need 2 pieces of aluminum foil, a hot plate, and the chemicals that we are choosing. The first chemical we will be looking at is dextrose, which is a simple sugar made from corn or wheat. It's chemically identical to glucose, which is our blood sugar. Next, we will look at naphthalene, which is a 2-ring aromatic hydrocarbon. It's a white powder with a characteristic odor and is most commonly used in mothballs. I will also be using sodium chloride, which is most commonly known as table salt. Finally, I will be using sucrose, which is also known as table sugar. It's a disaccharide consisting of glucose and fructose, commonly found in sugarcane. For the actual part of this experiment, each chemical will respectively be placed in a corner of the hot plate, as the hot plate will then be turned on, and the chemicals will be observed as they are heated up. After about 3 minutes had passed since turning on the hot plate, you can see in the upper left-hand corner that the naphthalene began melting very quickly and then evaporated. It was the first out of the 4 chemicals to do so. After about 4 minutes had passed since turning on the hot plate and 1 minute had passed since the naphthalene began melting, you can see in the upper right-hand corner that the dextrose began melting very quickly as well. Not long after, the sucrose in the bottom right-hand corner also began melting, and the two melted very quickly. As you can see in the sped up portion of the video, the dextrose and the sucrose quickly began burning on the hot plate. I was waiting for the sodium chloride to begin showing any signs of melting, but about 6 minutes has passed and it wasn't doing so I decided to turn off the hot plate. You can see here the final results of part 1. You can see the naphthalene had fully melted and then evaporated. The dextrose and the sucrose both melted and then burned as the hot plate was continued to stay on, and the sodium chloride didn't show any signs of melting and stayed in its original form. In part 2 of this experiment, we will be looking at solubility of the same chemicals. In order to test the solubility of each of the chemicals, I used a 250 milliliter beaker and put in 1 gram of the chemical. Additionally, I used 10 milliliters of room temperature distilled water. I then poured in the water into the beaker with the chemical. I began quickly stirring with the stirring rod and seeing how long it took for the chemical to fully dissolve, and after about 2 minutes had passed, if the chemical didn't dissolve, I chose to stop stirring at that point. This process was repeated once for each of the chemicals. You can see here that the naphthalene didn't dissolve at all. The dextrose had fully dissolved in the water. The sucrose had also fully dissolved in the water. You can see that the sodium chloride did not fully dissolve in the water, which is why it partially dissolved. But you can see that the water is kind of cloudy because there's still some substance, and at the bottom of the beaker it had settled a little bit, even after having been stirred for 2 minutes. Now we'll be able to review the data that we collected from each of the chemicals in part 1 and part 2. We'll be able to connect that back to polarity and our intermolecular forces. As you can see, I made a table regarding the order of melting, which was reviewed in part 1, the miscibility or immiscibility reviewed in part 2, molar masses, the polarity, and the strongest intermolecular forces present for each of the chemicals. When looking at sucrose, we know that it was the third to melt out of the four chemicals, but that was about after 4 minutes had passed since turning on the hot plate. It was also miscible in the distilled H2O, which means that it had dissolved in the water. Because it dissolved in the water, and we know that water is a polar substance and like dissolves like, we know that that means that because it dissolved, that sucrose is a polar molecule. To further reinforce that, we know that because there's a hydrogen and an oxygen atom within the chemical formula of sucrose, that the strongest intermolecular force present will be hydrogen bonding, which also makes it a polar molecule. Similar to the sucrose, dextrose was the second to melt out of the four chemicals, but that was after 4 minutes had passed since the hot plate being turned on. It was also miscible in the distilled H2O, and like I mentioned earlier, since like dissolves like, and we know that H2O is a polar substance, that makes dextrose polar. And once again, because sucrose and dextrose are so similar chemically, they both have hydrogen bonding as the strongest intermolecular force present. We can see very clearly when looking at the naphthalene that this is a non-polar substance with very weak intermolecular forces. We know this because it was the first to melt on the hot plate after about 3 minutes and evaporated very quickly. Because intermolecular forces hold the bonds between the atoms in the molecule together, we know that because it melted very quickly, it means that the IM forces are very, very weak, and it was able to pull those bonds apart. Additionally, because the naphthalene didn't mix well and wasn't soluble with the water, we know that it's non-polar substance. After about 6 minutes of being on the hot plate, the sodium chloride never showed any signs of melting, and this can be interpreted because it likely had a very high melting point that couldn't have been reached during the span of this experiment. Additionally, we know that because the sodium chloride did dissolve in the water, even though it was only partial, that does make it a polar substance. We know that the bonds between sodium and chlorine are ionic, and when an ionic compound is dissolved in water, the ionic bonds are broken. This interaction is called an ion-dipole intermolecular force, or ionic bonding, and it's considered one of the strongest IM forces. Because the ion-dipole interactions are stronger than the ionic bonds, which are on their own known to be very strong, we know that this makes it 1, a polar substance, and 2, it has very strong IM forces.